and look at another piece of code that I ask students to do in assembly. Now, this is pure C here. This is pure C. And my question is, well, first of all, you all understand what studio.h is? stdio.h. Anybody unfamiliar with that? We've all seen that before. That's like including IOStream if we're in C++. Okay, what is this notation doing? There's only one thing that's kind of strange there. It's a function prototype, isn't it? It's like a prototype, except that it has this word extern.
So is it outside of that scope of that program?
Of which?
Of that program, it's bringing something into scope?
Okay, let's be specific, because when you say program, that's kind of vague. This whole thing is going to make a program. So extern says, you're right, you're absolutely right. Extern says it's outside the scope of this file. It's beyond file scope. Okay? So the definition, if anybody's looking for it, wants to look at the detail of string length fun, it is outside of this file. Don't look in this file for it. That's what the extern says. Well, if you don't have the definition, how are we going to run it? Oh, it's someplace else in an OBJ file, which will be linked to, right? Somebody else has already written it, stored it someplace, usually in a library, and when we are done compiling this unit, in point of fact, if we have a reference to a call to string length fun, that function, there's a call inside of this file. Without that statement, we'd get an error, right? You would see something that says unresolved external reference. You ever get that message? And usually it's from mistyping a function name. But the underlying reason for it is the function that you are referencing isn't defined in this file. Clear? So the extern says, you won't find it in here, compiler. It's not in here. So shut up when you start to think about, it's not there. Just be quiet. Because what's the phase after compilation? Oh, there's no phase after compilation, right? No, there's this rather important phase called linking. Otherwise, you'd have to rewrite every piece of code that was ever written. How many of you have tried to write IOStream? Anybody in here write cin? Somebody wrote it for you, and then you linked it in. Visual Studio linked it in for you. Okay? Same idea here. We're going to link in this function, as well as all these others. Picture clear so far? Okay. Then, we have a type def here. In chapter 13, we'll talk about type defs, user-defined types and type definitions. So what we have here is a type, which is a function pointer type, returns nothing, has no parameters, but it is a function pointer type. That's a type definition, little shorthand notation. And then we statically allocate a table, an array, 7 long, of what type? It says proc in front, doesn't it? Does that help? Okay, so it has the word proc, the word func in front of it, which is this name of this type. Clear? The type is pointer to a function, returning the void with no parameters. That's the type. Its name is func. Okay? You give it whatever name you like. Call it funky. Here's the data type of this array, square brackets, 7 long. Here's the name of the table, the array, proc pointer table. Its length is 7, and each element will take a pointer to a function returning void and void parameters. Is that clear? So down here, then, what does that line do? Takes the address, ampersand, the address of string length fun. Takes the address of the function and assigns it into that table, the 0th element. So this table now is a table of function pointers. So far so good? That was in one of the examples that Todd and Randy had in previous slides. And the size of the table is 7. And oh, by the way, ooh, what's those ugly beasts? Scanf and printf.
C.
Horrors, that's C, that's not C++. Where's my C in? Where's my C out? Right there. Right there. Printf, scanf. Does the same thing. A little different syntax, but does the same thing. All right. And then, I want to know, what in the world does that do? Just that one line. It's just the name of the array that we saw earlier. One of this array here, proc pointer table, with the data in it. Sub response, where response is a number, right, an integer number, and then left and right parent. So, Kenan, what does it do?
It's calling the function that is pointed to inside the pointer table.
So, calling the function that is stored in this table at this offset in that table. So it's the ith function, right? Is that clear? So in this context right here, the function name is anonymous, isn't it? We don't know what it's called. If all I saw was that, we'd have no idea what it was called. No idea what its name is. And would we care? No. At this point, it's an anonymous function. We've cooked up our data table in such a way that it's going to work a certain way. This simply references it, says go to that data table and use whatever you find there. No hard coding of the function name, right? No hard coding of the function name. Sometimes we call this sort of approach a jump table. In any event, this is in a while loop, and it says, okay, get a response string and set the response value to whatever, decrement it by 1, so we got a number. So maybe that's a menu choice. In fact, it is. Menu choice. And the call, instead of a big if block saying, if menu choice is 4, then call string length fun. If menu length is, or menu choice is 2, you've all written that kind of processing, right? Long if block like that, with specific function names in it. Here's a generic anonymous one. The only thing I had to do is one test to make sure that the boundary was okay. We weren't out of bounds of my table. But to branch to the chosen function, no if block at all. No if block at all. Is that going to be faster? Yeah, much. Is it going to be more flexible? Yeah, and here's why. We don't care what function name is in pointer table sub response, do we? We don't even know what it is. So that's data that I can put in someplace else. In this case, it's hard-coded, isn't it? But it could be a string, couldn't it? Could have been a string with a value assigned into here. Is that clear? Therefore, when I want to change what we do with menu choice 1, when we do with menu choice 1, I put in a response, menu choice number 1, I want to change what we're going to do. I don't want to measure string length anymore. I want to go calculate the square root of pi. I want something dynamic. Do I have to rewrite my program? Nope. The only thing I have to do is assign a different data value here. Is that clear? I think I mentioned DLLs last time, where when we want to do an update, Microsoft wants to update system Windows 7, provide a new set of drivers or a new functionality. Do they ask you to recompile your Windows 7 before you do it? Nope, they just say update this, and what it does is some data patching, much like changing this value to a different value. Is that clear? That's one issue. Some of you have maybe done some Windows programming, but a very central core part of Windows programming involves something we call a message passing loop, or a message pump. A message pump. So you get an event, you click a mouse, and some other window pops up. What's happened there is the mouse click gave you a coordinate, and that coordinate was passed into a message passing loop, and the subscript, if you will, was passed to your message pump, and we execute that other function. We don't know when or where what function is going to be executed. It could be any time a different one. We only identify it by its location. So Windows has as its core, I'm making use of a Windows message pump right now as I'm moving from here to there to there. Okay, based upon the mouse click, the process has gone through something very similar, much larger obviously, but very similar to this little while loop. Is that clear? So again, the reason for bringing this example in is one, so you see an example of using function pointers, but two, to make sure you understand that function pointers are not just something that Metzler spent 2 minutes talking about in some previous class. They will be back over and over and over again. Very, very important efficiency method in programming. Questions? Boy, I must be good. No questions, huh? Okay. Yes?
If like string length fun and all those functions are actually addresses of the functions, why do you need to address of them?
This is taking the address of?
Yes.
Yeah.
Well, isn't string length fun an address itself?
It is an address constant, yes. So truly, you could leave these ampersands off altogether, and you'd get the same result. this particular example makes a point. This is an address, we're putting the address of that thing in there. Yeah. Okay, good question, Andrew. Others? All right. Test on Friday. We have lab tomorrow. We'll see you tomorrow.